Hello class, I'm working out of your Algebra 1 book 5.6, Direct and Inverse Variations. To begin, we're going to think about the direct formula is at y equals k times x, and every time that you have a value for x, the y will increase because it's multiplied by a k value. And so it's going to be a direct linear proportionality. You might want to put this on an index card to remember. Direct proportionality or direct variation. Alright, then the inverse, the same. You might want to jot this on to an index card to help you. The formula is y equals k over x. And the graph will look like this. It's an x and a y. Alright, think about what you know about fractions. If the x in the denominator becomes very large, the y will decrease with that large denominator. If the x in the denominator is very small, then the y increases with that denominator. And that's why the graph looks like this as an inverse proportion, where it is approaching the x-axis but not touching or crossing it, and the same with the y-axis. It approaches the y-axis but does not touch or cross it. Theoretically, this could go on forever and ever with very tiny numbers as the x and y get approached from this formula. Alright, so you're asked to state whether each of the following graphs or formulas are inverse, direct, or neither. So let's go through the first 8 on page 218 just to think those through. I'm just going to make kind of a chart real quick as we think about them. Alright, number 1, A equals 2B. So I'm going to go to this slide. We're going to compare it. Remember, our direct is y equals k times x, and our inverse is y equals k over x. Let's compare. A equals 2b. Well, this goes right with the y equals k times x, where the 2 is the constant proportion of growth for k. So it's a direct formula. Number 2, y equals 7 over x. Direct or inverse? What does it mimic in the formula? Well, the k is 7, and it mimics the inverse formula. Number 3, let's try xy equals negative 3. Okay, we need to isolate y with algebra and see what it looks like. So divide both sides by x, and now you have y equals negative 3 over x, and that mimics the inverse formula where negative 3 is the k value. All right, number 4. y equals x over 3. Notice the placement of your x is in the numerator. Remember that we can have a fraction for k. 1/3 times x equals x over 3. So if k is a fraction, it kind of mimics the inverse formula, but remember that x is in the numerator, which we need for the direct formula. So this is a direct formula equation. Just that k is probably a fraction here. Okay, number 5. That's an inverse graph. That's exactly what the inverse graph looks like. Number 6. That's neither. It doesn't look like the direct or the inverse graph at all. Let's think about number 7. So in number 7, we have the fact that y equals k times x. What if x equals 0? Well, then y has to equal 0. And that puts us at the origin for a direct graph. So y equals k times x. If those values is 0 for x, then we always need to start at the origin for a direct graph. And then if we think about in the inverse graph, if x is 0, well, can we have a 0 in the denominator? No, because a fraction is parts of the whole. The whole is the denominator. And 0 doesn't apply. There's nothing for the whole that's available. We can't draw from anything in parts of the whole for a fraction. So the inverse doesn't work here either. So if x is equal to 0, then y is going to be 0, and that's the origin of an x and y axis. And that's where a direct correlation will move through or start or eventually get to, and the inverse correlation isn't viable. So this one is neither. And then number 8, it's actually the direct graph. I hope this helps, and I'll see you soon.